Hello everyone and welcome back. My name is Mr. Kovold, and in this video I'm going to be going over scientific notation. What is it and how to convert a number to scientific notation and from scientific notation to standard form. So let's get into this. So what exactly is scientific notation? Scientific notation is just a format in which you write numbers, and normally we use scientific notation for very large numbers or very small numbers. Why do we bother? Well, imagine having to write these numbers multiple times over and over again. That would be very cumbersome. And so we need another way of writing these numbers so that if we write them over, they're not taking a whole lot of space. And so it's a lot easier and to work with. So I'm going to show you how you convert this to scientific notation. The format that we're going to be using is this format here. Scientific notation is where you're going to take a number like this or this, and you're going to put it into this form here. So the form here is that you're going to have some number. This number is going to be between 1 and 10. It could be equal to 1, but it's not going to be equal to 10. So it's going to be between 1 and 10 usually. And then this is going to be multiplied then by a factor of 10, 10 to some power. And so that's the form we're going to put the numbers into, and that's scientific notation. So a few things about that before we go on to actually showing you that. A lot of people will talk about moving the decimal point to the right, and that's going to be a negative exponent. Or if you move it to the left, it's going to be positive exponent, uh, things like that. I don't really like to use right and left because depending on which way you're converting, the right and left get switched around, right? So rather than dealing with the idea of moving the decimal point to the right and how that's associated with a positive exponent or negative exponent. I like to think of it this way. So large numbers are going to have positive exponents. Small numbers are going to have negative exponents. And that's always going to be the case. That's always going to be something you can keep in mind and use regardless of which way you are converting, right? So if you're converting from scientific notation to standard, or standard to scientific notation, this will always be true, and this will help you out, and I'll show you how that works. Okay, so let's talk about the 3 steps of converting a number into scientific notation. So step 1, you're going to move the decimal point to the right of your first number, right? So whatever the first number is. So for this top number here, this huge number, the first number is the 3 here. So if there's no decimal point in your number, assume that the decimal point is at the end. That's always understood, that the decimal point is at the end of your number if it's not actually explicitly written down. So the decimal point would be there for that number. And so this 3 here is the first number. For this number here, the first number is the 3 again over here. The zeros do not count as numbers in this case. So the first number is your first non-zero number. So this 3 here would be the first number. So my first step is always to move the decimal point to the right of that first number. So in this case, I'm going to move the decimal point to the right of the 3, so right there. And then this decimal point, I would move it to the right of the 3 here. That's step 1. Step 2, put a times 10 next to the number. Now that you've changed the number, you're going to put a times 10 next to it. And then the exponent that you're going to put here, right? So we got the exponent here. That exponent, that little n, is going to be equal to the number of spaces you moved. So whatever the number of spaces you move the decimal point, that's going to be the number of the exponent. Now, again, I'll show this in a moment. And then finally, you're going to put a plus or minus for the exponent based on whether or not you have a small or large number. Now, let me go back to small and large. So that's relative. What's small or large depends on your perspective. in some way. So I'm going to kind of define what I mean by large and small. So by large, what I mean is 10 or greater. I know 10 is not a very large number, 11, 12, those aren't large numbers, but for the purposes of scientific notation, we will consider those large, okay? So for small numbers, those are going to be any number less than 1. So 0.1, 0.2, those are going to be less than 1. Those are going to be small numbers. So small numbers are numbers less than 1. Large numbers are going to be 10 or greater. So 10 is included as a large number. So now that we have cleared that out of the way and explained that, let's go ahead and apply that to these two numbers here. So let's do the top number. First step is I'm going to move the decimal point to the right of the first number. So my first number is a 3 here. So I'm going to go ahead and move the decimal point over. So I'm going to count 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18. And there's my decimal point. So I'm going to rewrite this number as 3.2. You don't need to keep the zeros. Okay, so now I have a new number because I've moved the decimal point. But I'm not changing the number when I write this in scientific notation. So that's why I need to multiply by a factor of 10. Every time I move the decimal point, that is a factor of 10. So to keep the same number but put it in a different format, I'm going to multiply by a factor of 10. So what's the number? Step 2, put times 10 with the exponent equal to the number of spaces that I moved. How many spaces did I move? I just forgot. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18. So my exponent is 18. Now for the third step, put a plus or minus for the exponent based on size. So is this a large number or a small number? Large numbers, 10 or greater. Small, less than 1. This number, definitely 10 or greater, right? Obviously. So that means it's a positive exponent. So you can either leave it like this, or if you would like, you could put a positive there. That's fine too. And so that is how you write this number in scientific notation. So that is the scientific notation format of this number. Let's go ahead and do this number now. So again, step 1, move the decimal point to the right of the first number. So here's the first number. So I'm going to move my decimal point to the right of that number. So I'm going to move again. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19. So there's my decimal point. So I'm going to rewrite this number again. Again, I don't need the zeros anymore. So that's my number that I have, and now I have 3.2 because I moved the decimal point. But to keep this number, I have to multiply by 10. Remember, every time I move the decimal point, it's like multiplying or dividing by 10. In this case, I'm dividing by 10, right? So in this case, I was multiplying by 10. But you don't really need to remember all of that. All you need to remember are the 3 steps. So I've done step number 1. Step number 2, I put my times 10, and now I have to figure out what the exponent is. Well, I moved it 19 times, so the number is 19. Okay, that's step 2. And finally, step 3, put a plus or minus for the exponent based on its size. So again, small numbers, less than 1. Large numbers, 10 or greater. This number is definitely less than 1. So that means my exponent is going to be negative. So I put a negative sign. And now I have this number written in the scientific notation, that format. And that, ladies and gentlemen, is how you convert normal standard numbers into scientific notation. Well, how do you go backwards? What if you're given a number in scientific notation and you're asked to write it in standard notation? Well, let me show you that next. Okay, so here I am. I have these two numbers in scientific notation, and I want to write these in normal standard notation. So what do? I am simply going to work backwards based on this understanding that large numbers have positive exponents, small numbers have negative exponents. So here I have, for this first number, I have a positive exponent. That means that this is a large number. So the first thing I'm going to do is I'm going to write this down. I'm going to take the first number here. I'm going to write it down. 2.6. That's the first thing I'm going to do. Now I have this exponent. Remember, the exponent represented how many times I moved the decimal point. So I'm going to move the decimal point here back 4 times. Now the question is, which direction do I move it? Do I move it left or do I move it right? This is where this is going to help you here, right? So I have a positive exponent. That means I have a large number. So I'm going to move the decimal point in the direction that gives me a large number. So here, if I move the decimal point this way, that's obviously not going to give me a large number. Moving the decimal point this way is going to make the number smaller, right? So I want a large number. So that means I have to move it this way. So I'm going to move it this way to the right to make a large number. I'm going to do that 4 times. So then I move it over here. 1, 2, 3, 4. There's my decimal point. I'm going to fill in the spaces, the empty spaces with zeros. And so my final number is going to be 26000. You can put a comma there if you want. So 26,000 is this number written in standard notation. Okay, what about this one? Same thing. I'm going to take the first number here with the decimal point. That's going to be 3.5. And then now I have to decide where I'm going to move the decimal point. Notice that I have a 5 here, so that tells me that I'm going to move the decimal point 5 times. And the negative here tells me that I have a small number because small numbers have negative exponents. So since it's negative, I know I have a small number. So I know I have to move the decimal point in the direction that's going to give me a small number. Again, if I move the decimal point this way, that's going to give me a bigger number. I don't want a bigger number. I want a smaller number. So I'm going to move it this way to make a smaller number. So if I move it that way, I didn't give myself enough room. Let me move this over 3.5. And I'm going to move it over 5 times. So this is 1, 2, 3, 4, 5. And so I'm going to put zeros in the spaces here. And I'll rewrite the number. So this is going to be 0.0000035. And we normally put a 0 in the front as a placeholder, like so. And so then this number is that number in scientific notation. And so that, ladies and gentlemen, is how you move back to standard notation from scientific notation. And again, all I used was this idea here that large numbers have positive exponents, small numbers have negative exponents. Not once during this video did you hear me say you got to move it to the right, you got to move it to the left. That you don't need to worry about. You don't need to worry about left or right. You just need to worry about that numbers are big or small, and that large numbers have positive exponents, small numbers have negative exponents. And that, ladies and gentlemen, is scientific notation and how you convert. I hope this video was helpful. Thanks for joining me. If this video helped you in any way, if you like this video, then please like this video, share this video, hit that like button, and also hit that like button right there. And also subscribe to my channel, hit that notification bell, and when you do, make sure you hit that all button so you can be notified by all the videos that I put out. And finally, put a comment down below in the comment section. Let me know what you think. Ask me questions. Let me know if there's anything you want me to cover in a future video. I would love to do that. Thanks for joining me and have